Hello, in this tutorial we are going to learn how to detect faces on images captured by the ESP32 connected to a camera. So this is the continuation of the previous tutorials where we started to learn how to obtain images from a camera, and basically now we are going to work a bit on top of that, and in this case we are going to be able to detect faces. Keep in consideration that here I try to do this tutorial as simple as possible because the functions that we are going to use, that we are going to interact with, are a bit more low level than we are used to when we are working with Arduino core, because at the time of recording this video there was no higher level wrapper that allowed us to use these functionalities using, for example, some nice abstractions. So we are going to go a little bit deeper. Besides, I typically like to put together some simpler examples to analyze the core and the basic functionalities, and then on top of that it makes it much easier to build whatever suits your application, rather than putting already a very complex tutorial about something very specific. Then it's harder to adapt or to understand what's going on under the hood. So don't expect this tutorial to be doing something very special. It is not going to show the images with the drawn faces on it or something like that. The only thing it is going to do is basically capturing an image, and then if some face is found on that image, we are going to print a message to the serial port saying that an image was detected, and we are going to count how many times this happened. Nonetheless, and one good example of this is the Arduino core basic example from the camera, such more advanced applications can be built after we understand the basic mechanisms. We can easily return an image with the faces drawn on it, so it's there. If you haven't yet had a chance to test that basic tutorial from the ESP32 Arduino core, I recommend you to do it. It's very interesting, and it covers not only the capturing of images but also the face detection. So now moving on to the actual code. So what we are going to start by doing is including this ESP-camera.h. Basically it will allow us to interact with the camera, and it will expose to us the functions to get images from the camera. It is the same library we have already used in the previous tutorial. And then we are going to need this fd_forward.h library, which will expose to us the functions that we need in order to detect faces on a captured image. So from this point down, there's a bunch of defines that basically define the pins of the ESP32 that are connected to the camera. Like we have covered in the previous tutorial, these are dependent on the camera board that you are using, or if you have a custom wiring where you got the camera and just wired all your the wires yourself to the ESP32. So this should reflect those pin numberings. In my case, I'm using, and let me just recap from other tutorials, this model HW818, which is a camera board model that already contains, it ships, in my case at least, it shipped with a camera, an OV2640, which is the one that I'm using also here on this tutorial. It already has a built-in USB adapter, and these pins that I'm defining here reflect this model. Just a note, so this model, these pin definitions were also taken from the basic Arduino example for the camera. There's another file there with the pin definitions from, I would say, the most common models of ESP2 camera boards. And in my case, this one that I'm using, it's not there, but it has the same pin definition as the AI Thinker model, which is precisely what I'm using here. So this part is specific from a board. You should adapt this code here, these pin definitions here, to suit your board. And the rest of the code should be generic for any board type that we are using. Don't worry about all the number of pins here. I'm going to leave a link in the description for the written tutorial that I have done on my blog precisely to cover these image detection, so you can copy and paste it from there which is easier than going through all of these in a video. So after these pin definitions, we are defining here an init camera function. Basically, it's just a function that encloses all the initialization of the camera. Like we have also done in the previous tutorial, we start by declaring here a struct of this type, camera underscore config underscore t. This is a struct that will hold the camera definitions. Here we are going to keep the assignment of the pins that we have defined before, some other parameters that we need to initialize that we have talked before on the previous tutorial. And then just here as a note, we are using a pixel format of JPEG, and we are using here the frame size QVGA because it is the recommended frame size. If we go here to the ESP32 project, which is basically one of the projects for face detection and recognition that is currently used by Expressive, or was put together by Expressive, the makers of the ESP32 chip. So if we go here, down here a bit, so the recommended resolution of the input image is QVGA. So this is precisely what we are going to use in our tests. So going back to here, we are then calling this ESP camera init function, passing as input the address of the configurations, and then we are just checking here if the result of this function call is okay. If it is not, we return as output of our init function a false, indicating something went wrong. Otherwise, we return true in order for us to be able to do simple error checking to see if the camera was correctly initialized. Then, just to finish here, our global declarations includes in this section before the setup, we'll need here a global variable of this type, mtmn underscore config underscore t. Mtmn is basically the model that is used by the libraries to detect the camera images. So it is one of the models that is used. So I'm not going to enter in details on this particular section, but there's some documentation around the web about this model. But basically this variable here, this struct here, holds those configurations, the parameterization of the model that we want to use to detect the faces. But as we will see below in the setup function, we are going to use some defaults. So we don't want to care about, at least at this stage, about the fine-tuning of the parameters, which is possible. It's documented what are the parameters that we can fine-tune. It is on the documentation of the libraries, but we want just to get right away and have a minimal example, and the defaults will do for us. We're also going to detect here an integer just to keep tracking of how many times faces were detected. So every time in the image we detect one or more faces, we are not going to distinguish by each image if we detected one or multiple images. We just want to care if we detected at least one face, and every time we do, we are going to increment this variable. So we are initializing it at 0, but later whenever we are detecting faces, we are going to increment it. So moving on to the setup function. As usual, you start by opening a serial connection so we can output the results of our program. Then we are going to call the init camera function and checking if everything went well. If so, if something failed, we just print here a message so the user knows that there's no point in trying to run the application because basically the camera failed to initialize. Then, like I've said before, we are going to use the default configurations for the model for face detection, and we can obtain a set of default configurations by calling this function here, mtmn underscore init underscore config. It takes no parameters, and it will return to us, like we have seen before. Let me just scroll up. It will return to us here a struct with the default configurations, so we can use and get started right away looking for faces in the captured image. Then we're going to write the rest of the code on our Arduino main loop. So we are just going to continuously grab an image, do some procedures here that we need to do, and then try to detect faces in the image. If we detect, we are going to print a message. Otherwise, we don't do anything unless besides the cleaning up of the structs that the data structures were located, and then we repeat the procedure again. So we can just put the camera pointing to something else, see that no face is being detected, then we can point the camera to our face, and we can see, okay, something was detected, and we can play around a bit with it. So, but looking into the actual main loop code, we start by declaring here a struct of this type, camera underscore fb underscore t, a pointer to a struct of this type, like we have seen also in the previous tutorial. This will be a struct that will hold the actual buffer containing the bytes of our image, and also some metadata like the width of the image, the height of the image, the total length of the buffer that contains the image in bytes. All of that is stored in a struct of this type. So after that, in order to get the actual image from the camera, we call this function, again taking no parameters. It is called ESP underscore camera underscore fb underscore get, and it will precisely return to as a pointer to a struct of this type, camera underscore fb underscore t, containing now the actual image that we have taken from the camera. And obviously we are going to use the variable we have declared before to store this pointer. And from this point onward, this is where things start to be new comparing to the other tutorial. So basically we need to take in consideration that the function that we are going to use, it is called face detect, and it is here below. It operates over a struct of this type, dl underscore matrix 3du underscore t. I'm not going also to enter in the details of this, so you can also look into the documentation to see the fields of this struct. But basically, this is it will be a matrix that will actually hold our image. So we are going to somehow convert from this format or from this representation to this one, and this format is the one used by the face detect function to apply the algorithm to detect the faces. So the first thing we are going to do is declaring here a pointer to a struct of this type, and then we are going to allocate space for it, space in memory. So to do so, we should use this custom function that is also exposed in the library that we have included, that it is called dl underscore matrix 3du underscore alloc. So all these names are very long and descriptive, but basically it is the correct way for initializing or to allocating memory for this representation of the image. Here this parameter for our use case, it should be set to 1. Then the second parameter should correspond to the width of the image, the third parameter to the height of the image, and the fourth parameter should correspond to the number of channels that the image has. Take also in consideration, and I'm just reviewing a bit of information ahead of time, but if we look into the documentation of this face detect function, it requires us to work with the image that is on the RGB 888 format, which has 3 channels. So when we are allocating this matrix, we expect it to have 3 channels. And at this point we have this matrix, but at this stage it doesn't contain any information about our original image. Okay, so we just allocated space for it. And recall from what we have seen in the initialization that we are obtaining an image in the JPEG format. And I just said that we need to have it in the RGB 888 format, which means that somehow we need to convert from JPEG, from our original representation, to this second representation and store it in our matrix. To do so, there's this function that we can use, fmt to RGB 888. It basically allows us to convert a frame, and here it is generically a frame because this function supports different frame types, okay, from JPEG to other formats, and it converts it as destination to RGB 888, which is precisely the format that we want to obtain. So as input, this function receives as first parameter a pointer to the actual buffer that contains the original image we want to convert. Like we have said, it is stored here in the data struct pointed by this pointer here that we have of this to this struct of type camera underscore fp underscore t. So it's there, and it's the actual frame with the actual data is on this field called buff. Okay, so this is the field that we need to access using our pointer to access the data struct that we have obtained that contains the original image. We need to access these buff fields. Then a second parameter, this function receives the length of this buffer containing the original image, the length in bytes. Obviously, the function needs to know the size of this buffer so it knows when to stop reading it. And again, we can go to our struct and access this length parameter, this length field that basically contains the length of the buffer. Other thing that we need to do is specifying the original format of the image. Like I've said, this is a generic function that converts from different formats to the RGB 888. One of the supported formats is JPEG. We could hardcode here the enum value, but just to keep this a little bit more generic, if in the future we want to adapt this code and capture the original image in some other format that is not JPEG. So basically you can also access the format of the capture image, again in this struct here, using the format field of the struct. And thus we can obtain here, it will return the enumerated value corresponding to the pixel format of JPEG. To finalize, we need to specify, to pass a pointer to the buffer that will load the destination image already converted to the final RGB format. So basically, we did not enter in details about how this struct is built or what are the fields of this struct, but basically it will contain the data, the buffer with the image on this item field. So it's here the destination buffer to which we are going to copy the image. So after this point, and let me just tell you something that I forgot, but we are not doing any error check to any of these function calls just to keep the code simple and compact. But obviously in a real case scenario, we should do so. We should check if the values are being converted, if we are obtaining pointers that are different to null. So be sure to do error checking on a real application scenario. Here we are not doing it just to keep the code more compact, but it is obviously an important thing to do for a robust application. So going back to the code, at this stage we have already copied the destination image in the destination format to our matrix. So we can already call this ESP Camera FB return function that will basically, we are going to say that for the next time we want to capture an image, we can reuse the original buffer, the original image buffer. Since we are going to do this continuously, it makes sense for us to reuse it. And since we already copied the image to the final data struct, we can release, or we can mark the original one as free and available to be reused. And then finally, after all this preparation, we can call this face detect function, and that will basically do the whole procedure of face detection for us. It receives as input a pointer to a struct of this type, representing an image matrix to simplify or to put things simple. So it receives a pointer to a struct of this type containing our image in RGB 888 format, and then a second parameter, it receives the address of the MTMN configurations. So like we have seen before, we have initialized them with some default values. We have stored them in a global variable, and here we are just passing the address of that struct to be used by the algorithm to find the images. Okay, and then this function call will return to us a pointer to a struct of this type, box underscore array underscore t, which basically, in case faces were detected, it will contain the boxes surrounding those faces. We are not going to look into detail. We need to do a very small analysis of this struct, but we are not going to look into actual detail of what it contains, because again, here we want to do a very simple tutorial to make sure that we are able to detect images. We are not going to draw them anywhere, so there's not much interest, at least for now, to understand the insides of these returned struct or a pointer to this struct. So basically, we are not going to go in that detail, but keep in mind that if no faces were detected, the pointer returned here will be null. Okay, so what we are going to do is, if this pointer is different from null, it means it is pointing to something that contains the found faces, to a struct representing that. We don't care, at least for now, what it does, but we are going to increment our counter with the number of detections. Recall again, we have initialized it in the beginning of the code. So we are just going to increment its value by 1. Then we are going to print to the user saying that faces were detected again, and this is the end time that we have detected faces. And then this is why I told that we are going to briefly look to this struct, but I'm not going to enter in detail on these parameters. But basically, we need to free the resources or the memory that was allocated to represent the boxes found. Okay. Keep in mind that we cannot use the regular free function that we are used to do when we are doing dynamic memory allocation. When we do, for example, a malloc and then a free, we cannot use it here, so we need to use this dl_lib_free function that is defined on the libraries we have just included. And then this is a function we should use, otherwise we are going to run into troubles. If you have seen my previous tutorial on how to test the basic example from the Arduino core, you might have noticed that I've said that I was not able to run the part of face detections. At the time I did not understand what was the problem. I did not dig much deeper into the code, but then I was looking a bit after finding out that we should call this function in particular. I found out that at the current code that is in master, basically there are a bunch also of frees of these type of struct, of these boxes that are returned by the face detection function. And as you can see, a regular free is being used, and this was what was causing problems in my attempts to run the face detection algorithm. After I've changed them before running the code, I've changed them in my local environment to use the function, the free function from the library, and it started working. So it's just a note in case you also run in similar problems. At least that fixed for me. Then, so as you can see here, I'm not going to go into detail. These are some of the parameters of the struct, and then the struct itself we need to free. So obviously we don't run into memory issues. After that point, we still have our our second matrix, the matrix with the converted image. We also need to free it, otherwise we are going to run also into memory problems, and that should be the end of our code. Then it will repeat again. And we can run this in the main loop. So I had this running for a while. So far, no memory issues were encountered yet. So everything seems to be working fine. So I've already uploaded this to my ESP32. As you can see here, some faces were already detected. So I was just looking into the camera. I'm going to try to do it again. Just keep in mind that right now I'm using my headset and headphones, and the lighting conditions are slightly different from when I uploaded the code, but I believe things should work. So as you can see here, I'm pointing now the camera to me, and even though I'm wearing my headsets, it is detecting my face. Now I'm going to put it pointing to the ceiling, so no longer faces are being detected. So as you can see here, if I put it back now, it is detecting again, and now I'm going to stop again, and no faces are being detected. Sorry for not showing this live, but I haven't yet mastered how to do these videos also with the camera, so it makes it easier for me just to record them like this. But you'll definitely have the chance to copy and paste this code and test it for yourself. So basically everything is working, as you can see. So far, no memory issues. I've already detected faces a couple of times. I've done other tests where I left it much more time pointing to me, and so far so good. Keep in mind that, like I've mentioned before, I'm using an OV2640 camera. So depending on your camera, things may vary a bit. I have here a good lighting conditions, so I have my lights turned on. So obviously your results may vary a bit depending on your lighting conditions or on your hardware setup. But at least so far it has been working very reliable to me. That's it. So I think it's a good starting example. Again, not very complex. So it's to start with the basic part, and now on top of that we can build some more complex code, like we have seen, for example, in the example of the Arduino core, the basic one, where it actually draws a box around the faces. So it's something feasible, as we can see for that example. So we can now start fine-tuning this code to suit our applications. Hope this helps you guys get started on your needs, on your Interact for the application you want to test. Hope you have found it useful. If so, please leave a like or subscribe the channel. Thank you very much for watching and have a nice day.